So for 10.5, really all we're doing here is taking our discussion of two-dimensional things like area and perimeter and stacking on top of that a third dimension to talk about things with volumes and surface areas, where for rectangular solids we have the formula V equals LWH. That is, the volume is given by the length times the width times the height, where essentially you can think of the action being done here as taking all of our infinitely thin planes and stacking them up so many times that we get some consistent height there, h. It's a little bit weird to think about. It doesn't exactly work that way in, well, the real world, but in the real world we don't really have perfectly flat things that we can talk about in that way, so 2D doesn't really fit the conceptualization of how we see time and space, so naturally it makes more sense to think in terms of 3 dimensions, giving us, well, volumes like this. So let's take an applied example here, because hopefully we are at least fairly familiar with this sort of thing already, and we don't need too much of a backing in terms of examples to understand how this works. Suppose you are about to begin work on a swimming pool in your yard. The first step is to have a hole dug that is 30 yards long, 20 yards wide, and 2 yards deep. You will use a truck that can carry 10 cubic yards of dirt and charges $35 per load. How much will it cost you to have all the dirt hauled away? And this means that yet again, we are returning to the deeply middle-class world of property acquisition and development. Hopefully all of you guys will get to a point where you get to worry about concerns such as these, but for now, we're going to have to indulge a textbook author's interest in having the nicest house in all of the suburbs. Anyway, here what we need to think about, for one, is the volume of the space being taken up by the pool, and 2, the amount of loads that we're going to need to empty that space, and then finally 3, how much that's going to end up costing in total in terms of a number of loads, and that $35 per load. So first, we want to get the volume, where the volume is, as we said, length times width times height. So 30 yards long times 20 yards wide times 2 yards deep. It's not going to be a very deep pool, where when we multiply these all together, we'll get a volume of 1,200 cubic yards. It's got cubic yards, much like how squares were a natural unit for measuring area. Cubes are a natural unit for measuring volume. We like thinking in terms of boxes for various largely French in origin reasons. Anyway, once we have our volume here, we can talk about how many loads this will take, where the number of loads is going to end up being the volume divided by the amount per load, where in each load we have 10 cubic yards taken up as given there. So the number of loads here will end up being 120 of them, because, well, 1,200 over 10 is 120. It's not so complex. Then finally, to finish this off, we need to see how much this is going to cost. So the cost in this case is going to be the number of loads, 120, times the cost per load, which is $35, for a total price there of $4,200. Not that cheap to build a below ground pool. So I guess why a lot of people go with the above ground options. It's more cost effective for your swimming needs, but then again you have to worry about flooding. Anyway, this is what we have here for our volumes of boxes, rectangular prisms, rectangular solids, depending on how you want to call that. Next, we're going to look at a different shape we can have. We are going to look at what happens with pyramids.